Biological activity in water is reflected in the rate at which carbon dioxide CO2 is added or removed. Plants take CO2 out of the water during the day for photosynthesis and put CO2 into the water at night. Animals put CO2 into the water all the time as they breathe. The figure shows the rate of change of CO2 level in a pond. At dawn, there were 2.6 millimole of CO2 per liter of water. A. At what time was the CO2 level lowest, highest? B. Estimate how much CO2 level enters the pond during the night from t equal 12 to t equal 24. C. Estimate CO2 level at dusk, 12 hours after dawn. D. Did the CO2 level appear to be approximately equilibrium? To determine the time when the CO2 level is at lowest or highest, we observe that the graph, which is the rate at which CO2 level is leaving or entering the pond, the rate is negative from 0 to 12 and positive from 12 to 24. T equals 0 represents the moment it is at dawn, and so this is the hours past dawn. From 0 to 12, it will be daytime, and then 12 to 24, it is evening time. And so from 0 to 12, we see that the CO2 level is decreasing. And from 12 to 24, which is nighttime, the CO2 level is increasing. And if we think of this at the rate at which the CO2 level is entering or leaving the pond, then the area between the curves and the horizontal axis will give us the amount of the CO2 concentration in water at time t. And so if it is the area, we see that from 0 to 12, as t increases, as t goes from 0 to 12, the area keeps getting more negative, which means the CO2 level is decreasing. And it is decreasing at its lowest point at t equal 12. After 12, the CO2 level keeps increasing, and it reaches its maximum at t equal 24. T equal 24 is the same as t equals 0. And so we conclude that the CO2 level is at lowest at t equal 12, and the CO2 level is at highest at t equals 0 and t equal 24. T equal 12 is at dusk, and t equals 0 to 24 is at dawn. Next, estimate how much CO2 level enters the pond during the night from t equal 12 to t equal 24. This is the area under the curve above the horizontal axis from t equal 12 to t equal 24. We are not given a formula, so we would need to estimate the area under the curve. We can use this legend. Each of the square has an area of 0.01. That's the height times the width, which is 2. And so this is 0.02 for each of the squares. We just need to count how many squares we can fit under this curve. Alternatively, we can use the number of rectangles to estimate the area. 1, 2, 3, 4, 5, 6. There are 6 rectangles, and we can use either the left or the right endpoints. If we count how many squares we can fit into this region under the curve and above the horizontal axis, then we will get the definite integral from 12 to 24 of the rate, which we will call it r of t dt, and this will be the area under the curve, which is the amount of CO2. If we can be a little bit careful and count the number of the squares that can fit underneath this curve, we see that there is 1, 2, 3, 4, 5. This and this will be 6, 7, 8, 9, 10, 11, 12, perhaps 13, and it will compensate this 14, 15, and these two pieces up here will compensate for the missing part that we counted in square 11, 12, and 15. And so there are approximately 15 squares that can fit underneath that curve. Each of the square has the amount of 0.02, so we will take 15 times 0.02, and this is approximately 0.3. And so there are approximately 0.3 millimoles per liter, because the rate is millimoles per liter per hour. And this is how much CO2 enters the pond during the night, from t equal 12 to t equal 24. For part C, estimate the CO2 level at dusk, 12 hours after dawn. We will follow the same procedure where we will count the number of squares above the curve and below the horizontal axis. The goal is to see how many squares can fit in this region. About 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and these perhaps 16. We will not count these because they will compensate for the missing part in the squared that we counted, perhaps between 16 and 17. But we approximate that there are about 16 squares in the region between t equals 0 to t equals 12. And so for part C, it is the integral from 0 to 12 of the rate dt. And we approximate that this is about 16, and each of the squares has an area of 0.02. So this is about 0.32. This should be negative because this is the area below the x-axis. It should also be negative because this represents the amount of CO2 that is leaving the pond. And the unit is still millimoles per liter. Do the CO2 levels appear to be approximately equilibrium? We would say so. Approximately, not exactly the same. The amount of CO2 level leaving and entering between daytime and nighttime is approximately the same.